Hello, my name's Rob and welcome to Swift Slots. Now I'm hoping that different people see this video from my normal slot car audience. Now if you don't know what this channel is, I create and modify and customize slot cars. But recently I bought myself a 3D printer. Now I'm absolutely hopeless at computers, so a 3D printer was quite daunting. However, I have a very deep history in radio controlled cars. In fact, my radio controlled car interest goes back way back into the 70s and probably predates my serious slot car interest by quite a few years. And there hasn't been a year yet since I was 8 years old that I haven't had a radio controlled car. Now the trouble is, slot car content and radio controlled car content doesn't really mix. And then you add a 3D printer into it and then you've got a completely unknown quantity with regards to making a video. But that's what I'm going to do in this video. I'm going to take a 3D printer and a radio controlled interest and I'm going to send it out to my normal audience, hoping that new people see this content and are also interested in what I'm going to do. So if you're not really interested in 3D printing and you're not really interested in radio controlled cars, then maybe this video isn't for you, but I hope you stick around to watch it anyway. So what on earth am I talking about? What I've done is I've gone on Cults and I found a fantastic 1/6 scale radio controlled hot rod. Now I love hot rods, and if you look back through my catalogue of slot car content, you will see there are a few hot rod videos in there where I've taken a kit of a hot rod, turned it into a slot car. Loved it, love those projects, they're really cool. So when I found this 6th scale radio controlled hot rod to be 3D printed, that really interested me. Now I have been told many times not to turn my 3D printer into a hobby, and I don't want to do that because I bought the 3D printer to make slot car chassis and slot car parts for this channel, but I really wanted to make my own special project with it on the side, but I hadn't quite found out what that was until this particular 1/6 scale car cropped up. I thought, I want to make that. So that's what we're going to do in this video, and I hope that you guys that normally watch my content enjoy it, and also other people that are interested in getting into 3D printing and also radio control would also see this video and they'll enjoy it as well. Now just to give you some context on my 3D printer, it's a Bambu Labs A1 and I don't know how to print, and I haven't really done it, I hadn't done it at all until I bought my printer just a couple of months ago. So this really is a beginner's perspective on how I'm going to do this project. So if you're thinking about getting a 3D printer or you've just bought one, this is probably a great video for you, because I was in that position literally only a couple of months ago and I was a little bit daunted by the prospect of having a 3D printer, but I did it anyway and I've actually got on okay with it. You can judge me in the comments below and tell me how well or badly that I'm doing so far. But so far I've been able to create small parts on Tinkercad, print them out, download files from other websites like Cults and MakerWorld and so on, print those out, sometimes modifying them in Tinkercad before I print them out to customize them, and also doing a little bit of customizing in the Bambu Studio that just before the slicer, so when it goes to print it all comes out exactly as you want it. So these are all new things to me that I've learned in the last couple of months, and I know a lot of people say if I can do it you can do it, and that's sometimes a little bit misleading because some people's skill level is rather higher than mine when they first start. But trust me when I tell you, my computer skills are exactly zero. I really am quite useless when it comes to computers. I don't understand the phraseology. I don't understand how other programmers' brains work. I just don't understand it. But I have been able to get on with my 3D printer to the most extent. And as my brother said, Google is your friend. If you have a question, write it in Google, and Google AI knows all about the Bambu A1. And using that little tip there my brother gave me, I've been able to navigate through the Bambu Lab Studio and through Tinkercad as well and get to where I need to be to make this awesome model. So let's go to my new bench. Now I'm going to use a different bench from my normal one because this is going to be a project away from my normal bench. So this video will feel a little bit different to my regular viewers. I'm going to kind of try and overlay some sort of history of my radio control car background within it, and we'll do a little bit of machine like I usually do as well. I just try and give you a little bit of background about me, about the project, how I come to find this model and how I find it, and we'll do a bit of an overlay as I go rather than the usual kind of format that I do. So enough waffle, you know roughly what we're going to do now. Let's get to my new bench and let's crack on and build this 3D printed hot rod. Okay, so while it's important to know about your 3D printer, it's probably more important to understand your slicer. Now this is something that I had no idea about before I bought my printer, but it's something that I've had to learn rather quickly. And on the face of it, it seems quite daunting to a beginner, as it did to me. However, it's not actually all that difficult when you actually sit down and think about it. So obviously I'm a beginner and I don't know everything, but there are a few things that I had to learn quite quickly and a few things that I learned along the way. And I thought it'd be very useful to explain to you the very basics of Bambu Studio and probably all you actually really need to know with regards printing out a basic kit. So I'm going to try and show you the basics as quickly as I can. Now I may bounce around a little bit because there are some features here that work well against certain parts and others that work against other parts. I'm going to do my best to try and explain to you the best I can how I found that I can work these tools. So I'll run through the basic Bambu Studio here. So let's start with the very basics. Now the one thing to understand with a slicer is you do actually need to make sure that all of your features are correctly allocated, because any of these features here that I'm circling now, if they're not actually featured properly, it won't print properly or it'll cause you problems. So it's quite important to understand all of these steps here and make sure they're all properly engaged to get a successful print. So first and most obviously, make sure that you've got your printer selected, your exact printer. That makes a big difference. It won't print unless you have your correct printer. So the next one is, you'll notice that I have a 0.4 nozzle. So the diameter of the nozzle here is 0.4. Now the printer as standard comes with a 0.4 nozzle, but I would also advise getting a 0.2 nozzle as well. You won't use that 0.2 nozzle very often, but when you do want to use it, you'll really want to use it because you'll want to print out some very fine detail. That doesn't happen a lot within the kit, but you will find situations where that 0.2 nozzle really does help you out, and I shall show you some of those in a minute. So the next one that you might want to think about getting, or you should get really, is actually a cool plate super track. Now this is just basically another plate for your printer, but it's rubber coated. And the reason when you get a rubber coated plate is because pieces stick to it much better than the standard textured PEI plate that your printer will come with as standard, assuming of course you've got a Bambu Lab A1. So the cool plate super track is a very useful tool, and you should be buying it really as well as that 0.2 nozzle and work them together, and you'll find you'll get a much better range of printing ability with the standard plate and also that rubber coated plate as well. So sync information, we're not going to bother about that. It's just syncing your printer and so on. And I'm going to assume that you've got a reliable internet connection to your printer, or you've got your printer hardwired in. If you've got your printer in your shed at the bottom of the garden, you can't get Wi-Fi, get one of those Wi-Fi boosters that plug into the mains and get Wi-Fi to your printer. It will make life an awful lot easier. Otherwise, when you get your plates all set up, what you'll have to do is get a G code and then download it to a stick and then take the stick out to the printer. It can be done. That's how I started my first printing. It is a bit of a pain though. I ended up giving up on that idea relatively quickly and getting a booster so I could get my printer online. Well worth doing. So flow. That's just to do with your flow of your material coming out your nozzle. We're not going to bother about that. Flushing volumes as well. I'm not going to go into flushing volumes. It's not something that I've bothered with so far, and it is what it is, but I'm not going to get into that. So you've got filament. So this plus a negative here simply adds filament. So if I click that there, you can see it's just added in this filament down here. And to delete your filaments, you simply click these little circles here and delete it, and it's gone. Or you can delete it with this delete button here. But if I add one here, and it'll add that one, that sacrificial one there, and then I can just click there to delete it as well. It'll delete the last one. So it'll always delete the last filament, But as you can see, I've got 6 filament here, it's blue, and I've got some blue pieces on my plate here, which I don't want to lose, so I'm not going to press delete up there, otherwise it would delete the last one, which is 6. So the next one you got here is this wheel here. Now this little symbol, just this one just here, I don't know what that is, let's not do that one, but this particular one here, this adds your material that you've actually got. So you just click it in this list here and it adds it to your list of generic PLAs that you've got, or materials. And so as you can see, I've got Bambu PETG high flow, I've got some Bambu PLA basic, I've got some Bambu PLA silk, I've got PLA tough plus, and I've also got down here some Sunlu PLA matte and some Sunlu silk PLA plus. So whatever PLAs you have, or whatever materials you have, you can add them to this list just by ticking these boxes. And then what happens then is your materials that you've got in stock end up in this list here. So if you click any of these, what they say in this box here, it brings up what you've got. And as you can see, there's my Bambu. So if you scroll along, I've got PLA basic, PETG, PLA, and then PLA tough. And then in my Sunlu, you can see I've got the matte and the silk PLA plus. So that's what that does. Now it doesn't matter how many colors you've got here, this is just a color palette that you can have to apply to your parts. This can get a little bit out of hand if you've got lots of colors that you're not using. So my advice would be to keep this list basically confined to whatever colors you're actually using on your plates over here. Don't get too many colors that you're not going to use, it just ends up confusing everything. So that's to do with that. Now, objects. This relates to the parts on the plate. So if we click this one here, we got this, well, if we click this one here, if I double click there, so this has highlighted this plate. So we've got 2 objects. So on this plate here, we've got plate number 19. And as you can see down here, we've got 2 objects. Hang on, no, that's not quite right. Let me just click on that one then. So we've got plate number 13, there's one plate there. And then we've got plate number 14 there. Right, here we are. Right, so now we've got plate number 14 highlighted. And you can see here we've got BL and BL, 1 and 1. So we've got the 2 parts on that plate. So if I click that one plate there, you will see that it's highlighted that top one. And if I click that one there, you will see that it's highlighted the bottom one. This one, I didn't actually highlight it, did it? Let me just click it again. There, it's highlighted the bottom one. Then we go back to the other side there. And do it again. There we are. So that's what that does. It's not really all that important to worry about the objects. Just know that your objects and your plates are all listed under objects in this section here. Global is the one that we really want to be focusing on, and the advanced settings. Don't worry about the non-advanced settings. We want the advanced settings because there's all the things down here that we really do need to understand to get a halfway competent set of printed plates. So the very first one is obviously quality. I've not touched quality. I've not felt the need to. This is a thing with Bambu Studio. A lot of the presets that you used to need for 3D printing apparently are all done for you in Bambu. It's taken a lot of the hard work out of 3D printing, where they've given you all these stats all down here. They've all been pre-worked out for you, dependent on the material that you actually use. Oh, the other thing I forgot to say, if you click on your materials, you can literally choose the materials you want. And if you click on this color chart here, you actually get a color palette. Now, sorry, I'm bouncing around a little bit, but so if we go back to the PLA, if I click off that for a moment, if we go to the PLA, my PLA here, my basic Bambu PLA, you've got this color 5 here. Now that relates to the Bambu filaments. Because I've told it that I've got Bambu basic, it knows how many colors Bambu offer in their basic range, and it brings them up here. More colors obviously there. So this is color number 5. Well, not my color 5 in this chart, but it's orange. I wanted orange. So this is the actual orange that it is. And it is actually orange 10300. That is the actual orange that I've got. So I can literally click that and it will actually apply that on the printer. And when you put that orange into the machine will automatically see that orange because they've got little tags in the actual filament as well. So it can see what colors are in the AMS light that I've got to my Bambu print, it'll see it on the light. So it'll automatically detect it. And if you're doing a project like this, I would advise getting an AMS because it's invaluable for doing all these printed parts. Trying to do all these coloured printed parts without an AMS can be done, but it's an absolute nightmare. You're better off just getting an AMS for £150, and then you've got all this extra facility where it sees all the colours automatically. So if you go to this Sunlu here, so I click off of that because I don't need that. If we go to this Sunlu here, now Sunlu has lots of different colours, and because this is a Bambu slicer, it doesn't actually allow for non-Bambu colours. So what you have to do is you have to choose your colours from various colour palettes. So you've got your hue here where you can see the different colours happening in that bottom hue there. You've got the slider one there. You've got your preset basic colours there to choose from. You've got this hue here where you can change the colour, and you've also got these pencils here. Now there's a colour in the Sunlu that I wanted, which is a copper. So I ended up using a copper, this tangerine, to simulate my copper. I've also got a silver in the Sunlu, so I used the silver pencil there. These are just ways of finding the colours that you want or you got within your non-Bambu colour range. So once you choose the colour that you want, you simply click it, and then you click off, and it'll add that colour. See, it's just changed it there to that blue there, so I don't want that. So let's go to the black and then press basically off, and it'll turn it back to black, and it'll turn all my parts back black. So that's that. So coming back to this bottom part here, so we don't worry about quality. You don't need to worry about quality at all. So the first one we want to worry about is strength. Now the first one we want to play around with is wall loops. So you can check that. Literally is just how many layers it uses to create the outer shell of your 3D print. 1 is very weak, 2 is absolutely fine. If it's something very strong, you might want to use 3 wall loops, and you use your wall loops in conjunction with your infill. Now take these particular parts here, for example. These are my fuel tanks. Now they're very high up on the car and they're quite large. So what I did is I made 3 wall loops on these as opposed to the standard 2, but then I cut down on the infill greatly to lighten them up on the inside. So wall loops up and down on this tab here. You do want to play around with that sometime. Most of the time you get away with 2. But if you do want to play around with the infill, which is the next thing you do need to think about, just scroll down, and then we got sparse infill density. Now by default this is set to 15, and that is what I used for just about all of this model, but not for everything, like I say. So these particular pieces here, I turned those all the way down to 3% sparse infill to knock the infill all the way down, and that worked really well and lightened them up and still had a certain amount of infill within the boxes. But like I say, 15 is your standard. Now some parts might need 100%, so we add in 100% there. Now when you ask for 100%, it will automatically tell you or suggest that it changes the infill pattern, because obviously it can't do weird shapes with an infill at 100%, so it just goes to a straight pattern. Now the reason why we might want to use 100% is because, hang on, just get rid of that, is because when we're printing out gears, for example, there are some gears over here, you don't really want hollow gears. So with regards to this particular plate that you can see here, I've dragged all these parts to this plate because these are door hinges, that's a strap, these are door latches, we've got a steering column there, and also a gear. Now I wanted all of those parts to be 100%, so I literally changed that to 100%, and then I was good to go. Now if I change that to, let's just go to triangles for example. If I click that plate and then change that to 100% infill and then come off of it, it's going to want me to change the infill because it doesn't support that particular pattern, and it wants to change it to whatever it does. So if you click yes, it'll change it to whatever infill that it wants to print at 100%. So that's how that works. So your infill is directly linked to your percentage of density of PLA. Like I say, it's 15%. Is standard, and the machine will be quite happy on 15%. And if you want to put any of these back, you simply click the red and it takes it back to standard. And these icons here are red because within each of those categories we've changed something. If we've changed nothing within those categories, it doesn't go to a red. It just stays like the quality is there, completely plain. So sparse fill density 15% standard. Most of the things are fine. Use something like 100% for gears, or maybe 3% for something you want to be quite light, and then you may want to change the grid pattern depending on what you're actually printing and how dense it is. And then wall loops, 2 is normal, 3 is nice and strong, 1 is very, very weak. So the next one is speed. Now you only need to mess around with one setting in speed, and that is the very first one, and that is how fast it prints the first layer of print. Now I found when I was doing a particular job that I was trying to lay down PLA at full speed onto a plate that I didn't want it sticking hard to. So what I used was this standard textured plate, because the print that I was printing was very, very fine, and I didn't want it sticking hard to the plate like it would rubber. So I had to print it on the textured plate, which is a slightly less sticky plate, but very good, but it was very fine. And I was finding that as it was laying down PLA, it wasn't really adhering to the bed at full speed because it was so fine. So what I did is I turned my initial layer down to 25% or 25 millimeters a second, and that was perfect. It slowed it right down, and I use that setting now on all of my settings, and that works really well. But the standard setting is 50, but I would turn it down to 25, and that only applies to the very first layer you lay down, because your first layer of any of your printing is extremely important. You need to make sure that your first layer is well adhered. So speed, just change the first one to 25, and that's good. So the next one is support. Now this you might want to play around with because it can get quite complicated if you're having problems. So the first one is support enabled. Now this is to do with a tree support. So it will actually automatically support things that need supporting. For example, I can show you the underside, if I can just scroll around here now and find a particular piece. There, this one here. So this is the back of the car itself, and you can see that it's got a very, very large overhang. If we just zoom in here and drag it in, you can see that that's got a very, very large overhang. Now that's got no chance of printing like that, so you do need to add supports, and there are different types of supports to be had. So if we click enable support, you've got an option here of tree manual. So the support itself looks like a tree and it's manual, so you put that tree where you want it to be. Then you've got other ones here. You've got tree manual, tree auto, normal auto, and then just off screen here there's another tree manual. So that is, if you go tree auto, normal auto, that will automatically put a tree in for you, but it doesn't always get it right. So that's where the tree manual comes in. So the actual shape of the tree, you can have default, grid, or snug. I go with default. Don't bother with grid, don't bother with snug, it's just off screen here, but just go with the default. That will be absolutely fine. Threshold angle is to do with how steep the angle has to be before it engages a tree. 25 to 30 is absolutely fine. And then if we come down here, we've got support base raft and support raft interface. Now these are quite important because this is to do with the color that the first layer support uses if it has a choice. So in the case of things like this dashboard over here, now I had a slight problem with my dashboard because if we look, if I can get this thing to move, it's a little bit slow. If we scroll around, the clocks that I've actually painted by hand go right the way down to the bottom of the print. Now what my slicer did, I've also got a blue down here as well. What it did is it took the silver just connecting on these two middle pods here, and it used that silver to back the whole thing because some of this needed a support on the underside. So it did it all in silver. Now that blue is so thin that I really wanted that blue to be completely solid, but because it used silver, it took away some of the density of that blue, which I didn't want. So what you can do is you can insist that it has the base and the interface in. You can choose your color. So what I could have done here, if I printed this the first time round, I could have chosen this blue here. So I can simply choose the color that I want it to dominate my infills. which is obviously I've just chosen blue. Then I would have got a little blue line across here, which would have been peeled off because it's support material. But the support material that would have been underneath this dashboard here would have been blue, and that would have solidified up the blue and made it better. So these infills are very, very useful, and you'll see how it all works when you actually bring it up in your slicer when you've done all the work. So that's what these are for, and they're worth investigating if you get a little bit deeper into colorizing your models. So the other one we got here is others. Now this is another important one, brim type. Now a brim is a brim that you can add around the edge of the model to make small things stick extremely well. Now I've got a couple of pieces over here on this particular plate here that I did want a brim on, because I actually printed these little windscreen wipers on my standard textured plate here. Now that doesn't stick as well because it's not the rubber one, it's the standard one. So because I didn't want these windscreen wipers to get absolutely bonded hard down and break when I was trying to peel them off the plate, I actually put them on the textured plate. But because that doesn't offer huge amounts of stick onto the plate, I added a brim, which added, literally what it says, it's a brim all the way around the model, which increases the surface area, so you can print fine parts onto the standard plate, so it doesn't bond as hard as it would do on the rubber plate. And you can change the width of your brim here using this particular feature here by simply adding in the number of millimeters that you want. You can do it whatever you want. You can do it 1.2, 1.3 millimeters if you want to, or whatever you want. 5 is the standard, but you can do it whatever you want. So that's a very useful tool to have, and you might use that for something like gears that you don't want a brim round. Now the next thing is flush into objects and flush into infill and supports. Now this is to do with using colors within the model itself where you're not going to see it as infill, and also when it flushes colors into the support trees as well. So sometimes you don't want to be flushing your colors into a support tree because you're wasting valuable color. Say you've got a gold, for example, or a color that you don't have much of, but you want to try and keep as much of it. So then you wouldn't want, normally when you have something like this back end here, now as you can see, I've actually got these two brackets here just in gold. Now what that will do is when it gets to the layer where that gold is, I can actually flush that gold into the supports. As the trees come up, it'll lay it into that support as well. Now that's wasting color, so you can turn that off and turn that on accordingly depending on what you're actually flushing into your model. You can turn that around. So that's basically what all these are doing in their basic format, and the ones that I've highlighted there are the ones that you might want to use as standard. So let me just come back to this tree, for example, because I did say that you use your tree in manual mode. So if you go to automatic tree auto, and then click on this one here, for example, and then go to infill, and support, is this icon here. It's showing you a block underneath an overhang, so that is your support overhang. So if we click that, then we can use these little icons here. So that's just a big round paintbrush. Don't know what that one is. That is an infill, don't really use it, and that's some nonsense that I'm not entirely sure. You really want this circle, and you can change the size of that circle just here. So if we bring this part into the middle of the screen here, and then I show you the underside of the model just here. Now as you can see, it actually is already pre-highlighted some of this, but I found in experience it doesn't always highlight everything. So if we get this paintbrush and make it about that big, and I put a dot, there's a purple dot there, that is where it'll also put a tree. I can make that dot much bigger, or I can make that dot much smaller. So if I go into this area here, for example, or in this corner here, let's say I wanted to paint more of that, so I can bring a nice big brush and I can literally sweep the whole thing, and it'll not only add in this area here the tree that it would automatically do, it'll also add in where I'm sweeping it as well. Now when it puts an auto tree in my experience, it doesn't always cover all of that area, and you can get areas that are a little bit of a problem. So by sweeping that whole area, it will guarantee putting a tree all over that, and then you can erase that just by resetting it on that button there. So that's a very useful feature between the support and this icon up here. So these icons across the top of the page are these ones here that you'll be also needing. You don't need all of them, and some of them I didn't use at all. So this first icon here is simply bringing in models from your desktop here. You can simply bring them in, or you can drag them in. So that's simply all that one is. Now this one here is adding a plate. So if I scroll down to here and I click add a plate, you'll see it's just added a plate down here. Now I can add as many plates as I want to, or I can delete the plates if I want to. Delete the plate there. So the next one is this particular one here, auto orientate. And I've just done that, and I didn't want to do that because it's orientated probably everything. So this is an auto orientate where it'll actually lay all these parts out for you automatically. Now the reason I've got so many plates here is because I've added more plates and I've divided up this whole batch of products into the areas that I want. So for example, I've got these parts here, the seating, which is actually done on a standard plate because they're nice big surface areas and they're all blue. Because I don't want any other colours, I don't want to be flushing colours and wasting colours, so I've grouped all the blue parts together. I've also made some custom parts down here and I've added those as well on a separate plate, all in blue. And I've also added this one piece here in blue on its own. Now the reason I added that on its own is because this is actually going on a rubber plate and it wants to actually have a brim all the way around it down here. So I didn't want a brim on these, I only wanted a brim on that, and it'll only put a brim on whole plates. So I separated this piece on its own, and then I put a brim all the way around because the surface area on the bottom of that is very, very small. So these are all unbrimmed, and they're all on a standard plate, and this is brimmed, and it's on the rubber plate, and it's got a brim on it as well. So that's why I made an extra plate, and I dragged this piece to a new plate. And you can do exactly the same all the way through. Now I gathered up all of these parts over here because all of these parts here all wanted to be on a rubber plate and they all wanted to be 100% infill, but none of them wanted a brim because I didn't want a brim on all of this springing here and the bottom of those gears, and I didn't want a brim on the bottom of all those hinges because the brim can be a bit of a pain to get off. So again, I made a separate plate, I dragged all the parts over and I actually put them on their own plane. It's very, very simple to drag a piece over. All you do is you click it, highlight it, and you drag it over and you dump it on the new plate and unclick it, and it's it's that simple. So it's that easy to make your own plates and organize your own parts into whatever organization you really want to have, whether it be all colored parts or all brimmed parts or anything you like, or maybe all body parts that you want. You can bring them all over to a plate and you can group them by type and by color and by how many color changes. Now obviously each color change that you make, you're wasting material, so you don't really want something like this steering wheel in amongst your seat, because every time it does a layer it'll actually swap the color to black, swap the color to copper, swap the color to blue, and it'll do that all the way up and it'll waste huge amounts of material. So you want to get as many plates as you need, and you want to group all the parts into as many common types of parts as you can possibly do. So as you can see, this plate over here, I've got these two plates, these pieces here, because they need to be in a silver. I wanted to put a brim on there and I wanted to seat that one down in a correct orientation, so they got put to a different plate because they're a slightly different parameter from, let's say, the silver parts that I've used that are all over here, because these are all on the rubber plate, but they're all unbrimmed because I've got the windscreen surround there. I didn't want a brim all around there, so they went onto this plate here to keep it clean and tidy. And obviously got the rear view mirrors. I didn't want a brim all around that to have to clean off, so those parts went on there as non-brimmed parts on a rubber plate in silver. So that's what we're doing with that. I digress slightly there, I know, but that's how you make extra plates. So this next one here is an auto orientate. Now, it doesn't always get it right, this particular feature, and also you can change the orientation further along in a minute. I will show you. So if you, for example, this ball here, if I highlight it and then press auto orientate, it will put that where it thinks that it should go. As you can see, it's not actually done it where I wanted it. So it's, yeah. So anyway, it hasn't done what I wanted it to do. So it doesn't always work particularly well with the auto orientate. It doesn't always make the best decisions. So I don't do an auto orientate. Well, we'll come back to orientation in a moment, because this one here is basically orientation as well. So we've got this one here, arrange all objects. Now that again it sounds great, automatically arranging all the parts on your plate, but it doesn't always work very well. It can be a little bit nonsensical, because this plate here was just auto orientated when I just made the mistake just a minute ago when I pressed that button and I said, oh, it's probably done everything wrong, and it has. This plate here has been auto orientated. Well, this particular boot part is supposed to be sat on this flat area here. I'm going to skip through and I'm just going to do something now to put that back, and I'll show you how to use that feature in a moment. So there we are, it's just orientated it now, and it's turned this one around, which I didn't actually want that to be there either. So I'm going to turn that back around. Now that is roughly where those parts were just a minute ago before auto orientated them. And if it tried to actually print those parts, it wouldn't have been able to. So as you can see, the auto orientate isn't all that clever, and I wouldn't use it. So the next one we've got is this layer feature. Now this layer feature is fantastic. I'm going to come back to my fuel tanks now. So if I click that fuel tank and then I click this auto layer and I increase these volumes here, adaptive, what happens is when you choose your height, I didn't do this, I'll come back to this one in a second. When you choose your layer height, go for the 0.4 nozzle, you can choose your different heights here. Now if we chose the 1.6, which is what I printed everything else on, what it'll do is it'll print at 0.16 layers all the way up. Now obviously as you come over a dome, you're going to get much bigger steps as you come around, because you're keeping your layer heights the same. So what this little tool does is it actually compensates as you come around curves, and although you've picked this standard 0.16mm layer height, as you come around a dome, it will change it automatically with this bar down the side here. You can see what it's doing, and it'll actually change it to make that transition super smooth. Even though you've chosen a particular layer height, it'll ignore it when it comes to a curve, and that is really good for changing the finishing contour of certain parts. Now I found that to be extremely useful. Now if I can just come back to what I want to do next. So let's come off that. Right, there we are. So that's a very useful tool. Things like the back of this body here, other things, very useful tool to have. So that's all that is. Now this one here is simply moves the distance, moves where you are on the plate. I've got a few too many items on this particular screen at the moment, and it's struggling a little bit to keep up. So you need to, let's see if I can get off of this for a moment, because it's really struggling, my computer. So that is what that one there is. That's pretty straightforward. This particular one here, I don't know where let's put that little barrel now. It's gone off somewhere, but it doesn't matter. So this next, hang on, this is right. So this next feature here, hang on, why can't I think my machine is struggling with power at the moment. So this particular rotation here is exactly what it says. You highlight it and you can literally turn it around. Let me just drag it over here. You can turn it and orientate it like this in all directions, and that's very useful for setting up your plate and turning things around. As you can see, I've done an awful lot of that on the plate over here. There's an awful lot of orientation that I've done simply by using this one here. Now this one here is something that you're not really going to use. This is a rescaling tool, and you can simply get your item. I'll use on this one because I don't need it, and you can literally drag it in that direction and also sideways as well. You don't have to use it in proportion. You can use it in any way you want. If I click it again, we can go to size, so I can make it wider and I can make it taller, or I can make it go in proportion. So that's what that is for. So the next one is the the mode for putting it down on the table, which is super important. So when this particular part here came into the slicer, it put it in there completely wrong. It's going to resize that a minute just so that it's moved it, hasn't it? So it put it into my slicer in this orientation here. If I can scroll, as you can see, it's completely wonky. Now most of the parts that come into this kit do come onto the plates nice and flat, but this particular one didn't. Now that's got zero chance of printing, but that's how it actually ended up on my plate. So what you can do to make sure that they're all laid on the plate is highlight it, and then you click this particular one, lay on face. And what it does is it shows you all these different faces that it can lay it on. And if you click on the face that you think is more favorable, this one for this particular case, it'll actually automatically lay it down straight onto that face, just like that, and make it nice and flat. And that is what you want. So that is what that particular tool there is for. Now, some of the parts didn't come onto this plate perfectly. There is a part over here, if I recall, that didn't actually get laid down properly as standard. It's one of these, I think it was, or maybe not. But anyway, it doesn't matter. One of these parts on one of these other plates also never came into the slicer, laid completely flat on the deck, and that was a problem. So it's always worth making sure that every single part is laid correctly on the table when you come to slice it, and make sure that it's going to print properly. So the next one that you want to do, well, not you're going to want to use this. The cut is a very useful tool. It's outside the parameters of this video, but we won't use the cut facility. So the next one that we've got is color. Now, color is quite a big thing. You're going to want to color some things. This isn't necessarily the best tool but to use this for, but we'll do it anyway because it's a fairly low intensity part. So if we click it, and then you click your color, you simply choose the color that you want it in, and then you can choose connect edge detection, turn it right up to full, and then you can click it and it does the whole thing. Or you can bring it all the way down and it'll just do certain areas. So if I click black now, it'll just highlight the certain areas that it sees, and you can change the intensity of the areas that it sees just by increasing the number on this slides graph here. And this is how you color parts. You can simply color them like that. So if we go back to a more complicated part, I can show you just to the level of painting that you can do. So this took me a little while to do because there's an awful lot of polygons. So if we come into this part here, highlight the whole thing, click color, and then click the color that I want. Let's go with black for a moment. Edge detection, and then bring that slide bar right the way down, and we'll zoom right in to this dashboard, and you'll see just how much work I've had to do to color this dashboard. So here we are. You can see all the different sections that it can see to color. Now if I choose this blue, because it'll be quite an easy one to see, if I scroll right in and I bring my edge detector, it's already down, it'll actually come down to here. Look, we can see tiny little areas that it can color. So that is actually a really useful tool, and you can color in all these parts to the nth degree, get it absolutely perfect. We can go back and change those colors again, and then we can change these back to silver. But also you've got another little tool that you can use for coloring as well, that being, click that back, that being this circle here. This is a paintbrush. So if you're struggling to get a color, say we didn't get this black the way we wanted it and we're struggling to sort of highlight that area, you can use this paintbrush. You know, you can make the paintbrush as big as you want, or you can make the paintbrush as small as you want. Choose the color you want the paintbrush in, highlight it there, and you can simply drag it down, and whatever it sees within that circle, it'll actually paint. And if we miss that bit, we don't want to go too leery with it all the way down there, we can come zoom in, we can make a paintbrush smaller, and then we can simply paint it like that, bring it all the way down to the smallest, and then we can just go right in and paint it like that. And that's how you color parts. So that is basically how you use the color, and you can add more colors by simply adding them over here, and that will give you all the colors that you want. So with regards slicing, let me choose something that's not too difficult, because this computer struggles a little bit with this. I'm asking a lot of this little computer. So if we choose this plate here, once we've decided what colors we want our parts, I'll change these to the same color, in fact, because it'll slice it a little bit quicker. So we can go to the full size, or that one there, and edge detection, and just click it and it'll do the whole thing. No, it won't if we do that one there, and then bring it to the full size. We can color it all, and then we can color this one here, color it, and go to the full size there, go to the infill there, just clicks it, and there we are. So now we got this plate highlighted, and we got everything on the plate that we want. We can then go to slice. Now when you slice something, bear in mind that the printing times have a lot to do with the nozzle that you use and the layer height that you've already chosen. I skirted over the layer height, didn't I? So each layer here is a different printing time. Obviously a 0.16 millimeters is going to take a lot longer to print than a 0.28. The qualities of all of these are pretty good, but they obviously get better with the finer you use. Now if you have a color swap in amongst that as well, like in the case of this back end here with the gold in the back, that's obviously going to be a long time, because you're going to have to color when you get to the actual that's not a great example actually. The best example is this plate here, and I have a suspicion that all my work has been wiped. It has. All my work has been wiped out, because I actually had this line here all in copper, and because I've been messing around with the colors, it's wiped it all out, which is a little bit of a pity, because I actually had that entire, let's go here, edge detection, and let's go to there. Now, a little bit too strong. Right here, there. So you can see there, I've got an edge detection there, and that whole piece there was actually copper, and it took me quite a few hours to paint that entire piece in perfectly all around the edges. And because I've been messing around with this now, I've lost all that work. But anyway, you can get the idea. This particular piece here had that copper all in there on both sides, and it also had the doors in there as well, and they had a copper strip running down them as well. So all my hours of work have gone, but never mind. But you can imagine, if you have it on a 1.6, which is what I did, each layer had to have a color change. It wasted a huge amount of PLA, and it took hours, because it spent more time flushing than it did printing. But I had to do it on this particular one. I just had to do it. So bear in mind, this is where you want to turn down the flushing into the trees for the color to make sure it only flushes in the main bulk cheap color. And also bear in mind that the layer height is going to slow down printing time with regards how many layers of color that you have in. So this is why you want to divide up all your plates into more generic colors. So keep in mind that the height of your print depends on how alters the speed of your print, and how many color layers goes into it as well. So that's something to bear in mind. So we'll come back to this plate over here, and we'll just slice it. And I just want to show you to make sure that you understand how to lay these parts down. So if we just go, once we've got the plate done, we can go preview, which is the same as slice plate. It does the same thing. And you can see it will generate here a tool path and layer height. So this is where we almost get to the printing stage. 3 hours 50 minutes apparently for this one, which is because I've got a fade on these to make, as I said before, with that fading over the top, so it changes the layer height to make a perfect contour. We've also got on here, we can see we've got a brim as well. And also this bar here shows you how it's going to lay up this particular print as it goes. And I didn't color this one fully, as you can see, so it's making that one look a bit weird. But we can zoom in and we can actually see the infill here, and as you can see, that's quite a sparse infill. So if we go to strength, actually it's set it back to the generic infill because it's unhighlighted in red. So we just got a 15% infill, which is what that is there, 15%. And as you come down, you can see that it's actually laying, this is layer 1, and then this is the tool path for layer 1. As you can see, it's going around, it's taking away, it's going to the other tools. You can see the tool just coming up through here. So this is what you've really got to make sure that you get right before you go to print. You have to make sure, and this is the one thing that I learned to my detriment on some of my prints, this is really important to do, make sure that you come down to layer 1 on all of your parts, and make sure that you've got this whole print fully in contact with your build plate. You cannot print if you don't have all of layer 1 solid down to your build plate. That's super important to know. If you don't have full engagement on the plate, reorientate the part and make sure that you do get full contact, because if you don't, you'll have your parts fail and it becomes a bit of a problem, and you've got to try and work out why it's failed, and it gets a bit of a mess. And not all of these particular parts will lay down 100% as you expect them to, and you can get a little bit of a problem, especially with things like on this plate here. You can have things that don't lay down quite right, and then they'll never stick properly. Say for example this wibbly wobbly spring here, if that spring doesn't go down 100%, it won't stick to the plate and you'll have all sorts of problems. So once you've got to your slice, you can then simply, hang on, let me find another plate, a plate here that I can preview it, and then we can go back and I'll slice plate, and then I can, so once you've got the plate here and you're happy that it's sliced properly, you can then simply go to print plate. And as you can see, you've got your colors here now. Now my printer's not on, so it's not going to show this quite right. It's not going to sync because the printer's not on and it can't see it. But if you've got Bambu filament, it automatically knows where it is in your AMS, and it'll allocate that color to the 4 slots. I've put some up here anyway. But if not, all you need to do is you need to click on the color, and then you can allocate it to the spool. It's not doing it now because it's not seeing my printer, but it would have 4 spools, and you simply click on the color and you can allocate your color to the spool that you want if it's not seeing it in Bambu. It's that simple. And then once you've got all your colors allocated to your spools, you just press send and it'll send it to the printer and then print. Now I wanted to just come back and show you something else that I want to show you here. So in the instructions for this particular car, it tells you about adjusting the surfaces of the radiator. So here is our radiator here. Now, as you can see, when it comes into the actual slicer here, it's a solid thing. So if I highlight that again, I just want to change its color to silver just because. So this particular one here, as you can see, it is a solid thing. Now the instructions call for this to actually be different from what you see it on screen. It's a little bit slow because it's taken the time to click all that off. So what the instructions call for is to remove the surface shells. So this is a very useful thing. So if you go to strength, the surface shells are here. Bottom shell layers 4, and that literally refers to the surfaces on the bottom plate. So it calls for 0. So bottom shell layers at the moment, I want to reduce that down to 0, and you'll see what that does in a minute. And top shell thickness, no, not the shell thickness, sorry, top shell layers, there it is there. So it's saying 6. So that's 6 layers on the top to give you the strength. So we're going to turn that one down to 0 as well. And what that's going to do is it's going to strip out the top and bottom layers of this to just reveal the infill. So if I just slice that now, I'll give that a moment just to slice up, and you'll see what there. So what it's done, I've also got a brim on it as well, so we don't want that brim. So if we go to others, we can remove the brim, just revert that down to auto and it won't do it, and we can slice the plate again and it'll re-slice it. It's still got a little bit of color in there. Sometimes I can get it to color up and other times not. So these pieces here refer to the support, so it's put a little bit of support underneath there. By happy coincidence, it's added a bit of a blue because I've not got the colours right, but it doesn't matter. But it's better for this particular instruction as you can see what it's doing. So it's adding supports, a natural tree underneath there, and that supports the tubes. But also what you see now, by taking away the top and bottom shell, you now see the actual internal, and it's starting to look a little bit like a radiator. And that is what the instructions actually call for on the instructions for this particular car. So I'm going to just change this to a slightly more reasonable shape of a radiator because I did mess around with that just a little bit. So there we are. So if we go back to preview again in the slicer and slice it again, go back to what we saw. Now the next thing that you'll notice is that the pattern is not really radiator-like. Now this is something else that I wish that I'd have seen when I did my original one. So if we go back to strength, we can change the pattern quite easily to its gyroid at the moment, sparse infill pattern. Now if we change that to a grid, Bear with me for a moment. I just got to try and find the grid one. We can't find the grid. We'll go for that one for a second. You'll get the idea. And we'll slice the plate again, and it'll change the infill pattern. It's not, obviously that doesn't look like a radiator, but if we wanted to change the infill density to make it look more like a radiator, we could change that to say 75%. And then if we slice it again, it will change that infill pattern, and it'll make it even more like a radiator. Obviously the lines are going the wrong way. There we are, look. So that's changed it to that. Now if you look at the wall thickness on this particular part, the outer walls here, it's very, very thin. I wasn't happy with that with mine, so you can change that by going into the wall thickness, and you can change the wall thickness in strength. Now I added, there you got 2 wall loops here, so if I changed mine to 6, so if I change that to 6 and then slice it again, you'll see that we'll have there's a much stronger wall all the way around it. And that's what I did on my radiator. I actually used the wibble wobble pattern you'll see in the build. But that's how you can change the thickness of the walls and what it has an effect on the actual model as well. You can change the sparse density infill by changing the percentage, and you can take away the bottom and top layer shells to show all the infill if you need to. This is a very rare instance, but I thought it's worth showing how you could actually change the layers of the material and get a totally different effect. So that is basically a very basic outline of how to use Bambu Studio. I know it seems like a lot, but really it is quite logical when you get down to it. And also, if there's something on this studio that you don't understand what it is, if you click on it, say here, it'll actually go on the internet and it'll show you exactly what that means. So here we are, this is the internet now, and it's literally brought all that up, and it shows you exactly what that particular feature does and why and how. So all of these things here are very easy to research. Also, Google AI is your friend. If you don't understand anything about this particular feature here on any of these things, you can always go in and ask Google AI, and it knows all about how to work this, and it's an extremely clever and knowledgeable tool for working Bambu Studio. Another thing I just want to show you on this particular one here, this plate here was also auto arranged just a minute ago, and as you can see, it's actually arranged this plate here. That's the front windscreen that you see on this car. Ridiculous, because it's going to have a whole load of supports all scarring the front of that model. So this is another good reason. If you highlight there, you can do automatic face, and you can turn it round and choose that face, and there we are. It's just dumped it straight on a much more reasonable, turn this to top, it's put it on a much more reasonable orientation for that particular part there. So that's quite enough of that, I think you'll find. So what we'll do now is we'll leave all this here now, and then we'll go to the bench and I will show you all the parts that I've printed out, and then we'll get on and build this hot rod. And here we are at my table. And as you can see, I've printed off all the parts needed to build this hot rod model. Now this isn't actually all of the parts. I've had to print off this entire tray of parts as well to complete it. So that should be all the parts needed to make the actual car. But I've also found this driver figure on the internet, and I put him on the bamboo slicer, and I've chopped up his arms because I want to fit his arms to the steering wheel so his arms will move with the steering wheel and with the front wheels. I've also made his head separate because I want his head to move with the steering wheel and the front wheels as well. So a little bit of animatronics there. I think it'll bring the car to life a little bit more. Now I've actually printed off these tyres in a PLA because I want to use these as masters to actually turn these into 40 Shore silicone rubber. The instructions call for these tyres to be made in TPU, but with the best will in the world, TPU is not the best rubber for grip on a model car. It is rubber, but it's not very grippy. So that's why I printed those off in PLA. Now also the instructions call for some hardware. So what I'll do is I'll just show you the hardware that I've had to buy with this kit as well before we get on to building the chassis. Okay, so this kit does require some hardware, and here is most of it. Now, there is a speed controller to come for about £25 or $35. There's a battery and some servos and a receiver, but I've got all that waiting in the wings. But this is the main part of the requirements. As you can see, I've got a list just there of all the hardware that you need. And the first thing it asks for is a motor. Now, it says a Surpass brand, and I happened to find the Surpass brand very easily, so I just went with that, although there are many other brands that you can have of this exact same motor. And this particular motor cost me £19 or $25, and it's a 3530 brushless outrunner. Very easy to find, so that's what that is. As you can see, this is actually the Surpass brand, and you can see it comes with a set of fittings as well. Probably won't use too many of those, but that is the exact motor. Looks a bit small to me for this massive car, but the gearing is going to be something different, and I can always run it on a few extra cells if it's not all that fast, but I'm sure it'll be perfectly good. So that's the motor. So the next thing we've got is this belt. Now, this belt cost me £4.50 or $6, and it's called a 144 3M06. Now, that seems like a lot of nonsense, but if you break it down into parts, it's easier to understand. So 144 is the actual diameter of the belt. 3M is the pitch. It's a 3mm pitch, so you can get 2M and other M's as well. This is a 3M, so it's a 3mm pitch. And 06 refers to the width, so it's a 6mm wide belt. So once you understand what the numbers mean, much easier to find on eBay. Now, this kit requires a lot of bearings. There's 20 here, although it calls for about 28. So I do actually have 3 tubes of these, but I've been fitting them into parts as I go on this kit to make sure that everything all fits nicely. And these particular bearings here are called a 10-15-4, which is a 6700ZZ bearing. So 6700ZZ is the actual size that you need to find these bearings on the internet, and I got 30 of these bearings for only £12. Took a bit of finding to find them for that, but normally they cost about £10 a tube. So I bought 3 tubes. I say one of them has been discarded in the model so far. So these actually cost me £12 for the whole lot, so about $16. So they're really cheap, and you don't have to have the metal shielded ones, which is the ZZ prefix. You can have rubber shielded ones or open ones, depends on what you want. I'm not going to be asking a great deal of this model, so the metal shielded ones would be absolutely fine for me. And then the other bearings are the 8, 12, 3.5 bearings, which comes in at a 128ZZ. Now, it calls for 3 or 4 of these. I've used a couple of them already, and I've been sinking them into parts as I'm printing them off as the kit requires. So that's why I've not got a full complement here, but that's what these are. And these cost me £5.50 for a set of 5, or about $7. So the other thing it requires is a spring. Now, this is a little bit of a, oops, that didn't go too well, did it? Now, this kit calls for this particular spring, which is an 18mm diameter, 55mm long, 1.2mm wire. Now, I couldn't find any 55mm long pre-cut springs, so I ended up getting this piece that's 300mm long, and I shall chop it up. Now, there is a certain line of thought on the Facebook group that supports this car, saying that these springs are not strong enough to support the car at full weight. So you have to thin out the thickness of the printing on the body to make it lighter or whatever. Now, I'm going to try and use this spring and see if that's right. But if it's not right, I've actually ordered a 1.5mm diameter wire and a 1.8. So I'm going to try and go up spring tension to get the tension right. If not, I should build some double shocks for the back end. Say use the 1.8mm springs maybe on double springs on the back end and see if that works. I shall play around. But there is actually a non-suspension version of this car that you can print as well. That also comes with the instructions. When you buy your file, in the instructions and in the files, you can actually get a non-suspension version which has a bit more detail on the front end instead of the springs. But I've gone with the suspension model because that's what I wanted. So I'll be playing around with the spring. And you can see the actual end of that spring is very nicely flattened. And I'm going to be showing you how to do that, because most people just cut it and leave it all spiky on the end, and that's not really how you're supposed to cut a spring. So later on in this video, I'll show you exactly how to make the end of that spring nice and flat, and it's really very easy. Now, when it comes to nuts and bolts, this kit requires an awful lot of nuts and bolts. So as you can see, I've been into my local town and I bought this little holder, and I printed out all the sizes, and I bought all of these sizes ready for this kit. Now, there's a lot more here than I actually need, but I was finding on eBay This normal sellers, oh sorry, this spring costs about £6, about $8. So these screws here in the UK work out to be approximately £7 or about $10 for 50. Now that's quite expensive because this lot here soon racks up in price. So I was able to hunt around on eBay and I managed to find the Chinese sellers that are selling 50 screws for only £2.50, so about $3 for 50. So there's about 100 in there, and then there's about 50 in everywhere else, and it cut the cost of these screws right down. Now I did actually cheat a little bit because with regards for this, say the M3x8, I only needed a couple of those sizes, so I didn't buy that size. What I did is I bought the M3x10, which it does need. I don't need as many as that, and I chopped them down to make them shorter. So I just got a piece of metal that was 8mm deep, and I popped the screw in the metal and then chopped off the ends with an angle grinder and then smoothed off the end with a wire wheel, and I turned some 10mm into 8mm. Exactly the same with these 16s. I took a few of the 20s, cut the ends off, turned them into 16s because I didn't need many. It wasn't any point in buying extra screws. So that's how you can sort of economize some of the size screws when you don't need all that many. So there's no point in buying 50 M3x12s. I only needed 3, as you can see, so I just took a couple out of the 16s, chopped them down, and then I can make my 12mm there, and that works perfectly well, does the job. So you can economize on your screws by doing it that way. As you see, there's quite a lot there. So between all this lot here, I paid about £77, so I guess was about $85 for all this lot here, and that will get me started. So with all that said, let's get all the chassis parts on the table, and then we can start bolting this kit together. Okay, so here we have all the basic parts of the first part of the basic chassis all laid out, as you can see, and they print off the printer extremely nice. Now, as I said, these are all printed off in 0.16 in the high quality setting on the slicer, and they print out very, very clean and tidy, and they don't take too long to print per set. So now it's all laid out, we can now screw the slot together and get the first stage of the chassis all built up. So my RC journey started in about 1977-78 when I was 7 or 8 years old, and we had what we called a Sonic car. And as a handheld clicker, the car had a single driven wheel on the underside, and when it went in reverse it would turn through 90 degrees. So as you clicked the car and made the car go in reverse, it would reverse and turn at the same time. When you wanted to go back forwards again, you click the car again and it would run forwards in a straight line. A little bit weird driving around the house in this sort of weird forward and reversing turning motion, but it was great fun as a child. And then in 1979, my father came home with the Tamiya Sand Scorcher, and that changed everything. It changed my life completely, and I've never been without a radio control car ever since, and I'm now 56 years old. So my father used to have a stand, and we used to go around the south of England with a stand selling model trains and model toys, along with many, many other traders. And I used to know kids in those stalls, and we used to meet up all around the county for several years, and we all had sand scorchers, and we'd spend hours playing with those cars. Absolutely loved it. And then eventually that car disappeared after 18 months, and it was left to 1981 before I actually got my own proper radio control car. The only thing is, I never did receive that car. Apparently it got bought and it was broken, and instead of taking the car back to the shop, my parents decided to give it to a family member who was an electronics engineer, and he promised he could fix it. The only trouble is, he never did, so I never got that car. I had to wait to 1982 before I had my own proper radio control car, and it was a silver truck. It wasn't quite a hobby grade, but it wasn't quite a toy grade. It was something in between. Absolutely loved that car. I spent 18 months absolutely running the wheels off of it. We took it all sorts of places. We used to go to a four-wheel drive off-road, real off-road type event every couple of months, and we'd take it there as well, the model car, the radio control car. So as a 12-year-old child, I used to play with my radio control car while the big four-wheel drive real stuff was bombing around the place, getting filthy dirty. Absolutely loved that car, loved it to death. I don't know where it is now. I sold it many, many years ago, but fond memories of that car. And then in 1983, I finally got my first proper radio control car, and that was the Tamiya Subaru Brat. I got it for my 13th Christmas, so I was 13 years old, and that absolutely changed everything. I loved that car. And I built it up by myself, and then I used to run it at school, used to run it around the park, used to run it everywhere. Completely and utterly loved it, ran the wheels off of it to death. And I think I kept that car for a good 6 years or so. I think I eventually sold it to my woodwork teacher at school, right at the very end of school, and I upgraded that car for a Tamiya Falcon. And that car didn't get as much use because I was just about then to get myself a proper four-wheel drive racing car that I would then take to racing when I got my driver's license. And there we are, that's step one finished, that being the construction of the basic chassis. And it all went together extremely well. The fit and finish was perfect and all the screws had just the right tension, and I was very happy with the way it all went together. And for it being about 18 inches long or more, it's remarkably stiff. I'm very, very pleased with it. Now, the only thing that I did deviate slightly from the instructions called for an M3 by 6mm screw to go in the motor mount here. I changed those to 10mm long. 6mm long seems a little bit short. I also skipped ahead slightly and I fitted these rear rails, so it doesn't actually affect anything, but the instructions called for putting one screw to hold this body mount in here, and that would have been a bit weird because there would have been a gap there. So I slipped in these two rear chassis rails just to finish this section and to make more sense of fitting in the screws. It just solidified the back end, and I swear I've got to be anyway. So with that all done now, I think it's probably time to move on to the front suspension and fitting the front grille. And moving on to the next stage of the build, that being the front suspension and the front grille assembly. And here is the radiator that I showed you from earlier on, with its infill completely exposed, having its top and bottom shells removed, and then 6 walls added around the outside. Now, I would have liked a much nicer looking grille, but unfortunately this is the grille that comes with the suspension files. Now, if you go into the unsuspension files, or the non-suspension car, you actually get a radiator that looks much more like that. Now, I didn't spot that when I was printing out this radiator, so what I had to do was import this file for the radiator into Tinkercad, and I was able to overlay some parts onto it to create this overlay here, which gives you a much better impression of a proper radiator. I think you'll agree. But if I'd have just pulled the file from the non-suspension car, I would have gotten this look right off the bat. However, that is where we are with this grille, so I'm going to use it. Now, what I'll simply do is super glue this overlay onto my radiator, and then in the non-suspension files you will also find a really nice radiator fan with its fan holder. Now, this isn't present in the suspension version, but it is present in the non-suspension version, so I've taken that from that file set and I've added it to my car here, and I will simply glue and screw this particular fan holder to the back of the radiator, and that will get me to exactly where I need to be. Perfectly good for this build. Right, okay, so let's crack on. Let's get all these bits onto the chassis. So when I was a kid, I used to live on a farm miles away from anywhere in the middle of Wales. And every month I'd get 2 magazines, Radio Race Car and Radio Control Model Cars. And every month I'd have to cycle into our local village to collect them. It's a 6-mile round trip up and down all sorts of hills. So I was very well versed on the model car scene during the 80s, even though I didn't actually have a car or was able to get to any meaningful shops. So I was very well aware of what was working on the track during the 80s, even though I couldn't actually get on a proper track and race. But with this in mind, I still chose my next proper 4-wheel drive model car, and that was the Kyushu Optima Pro. Now, I loved that car. I drove it all around our farm. I'd made all sorts of tracks up in the barns. I'd even tried to dig up some of our fields to create a club and create a track. I tried to create a track down in a local village with the help of the council as well. I made my own rostrum that was huge. I had to get a local farmer to take it down to the local village for me on the back of his trailer. But nothing really happened because I was a kid with no transport and nothing else to do. So I eventually got a job. And then I ended up in the digs, and I was very bored in my digs, so I decided to start buying some other cars to play with until I passed my driving test. And one of those cars that I've got was the Midnight Pumpkin. Now, I really wanted the Tamiya lunchbox, but in the local model shop that happens to spring up in our local village at that particular time, they didn't have a lunchbox, but they did have a Midnight Pumpkin. So I settled for that, and it was okay. I really wanted the lunchbox, but the Midnight Pumpkin was okay. But I decided I was going to up my game slightly, so I ended up going for a Kyushu Double Dare. Now, if you don't know what that one is, that is basically a monster truck, 2 motors, 4-wheel steer, and 8 shock absorbers. And I thought it was I thought it was awesome until I got it and actually tried to drive it. And that concludes the majority of the front end build. And you can see the front grille in place, all the suspension in place and all fully working. The servo is in place and all the steering links, and also the back of the radiator and the cooling fan. I will just chop off the top of that servo once the build is finished and I finalize the geometry. But other than that, the steering is all working. If I turn the steering wheel, hit the servo, you can actually see the wheels turning absolutely perfectly. So the only thing that's really left to do to finish this front end off, that I'm not actually going to do for a minute, is fitting these spring holders. They're not shock absorbers, they're just spring holders. So I shall leave those for a later date because I want to get the springs just right. But the way that they work is you simply print off the two halves. You print off the shaft with a pair of bearings to go in the bottom, or spacers. You print off the bottom spring keep and then the shock body here. And the way they simply work is you put the shock absorber into position on the shock body, then you put the other half on top to trap it, and you take your spring or your shock keep, or whatever you would call it, you pop him onto the bottom of the shock there. You take the spring keep, you put him on, give him a 90-degree turn, and he locks into place on the underside there, and the shock absorber works 100% perfectly. And then there's one spring that goes in there. These work really, really well, but I'm going to leave them for a later date because I want to just play around with the springs when the whole car is finished. So with that all done, I think it's now time to move to the back of the car and sort out the rear diff. So here are all the parts for the locking and unlocking differential, and they're all printed in PETG, apart from the outer casings, which are printed in ordinary PLA. All the parts that are under tension for this car are all printed in PETG for a little bit of extra strength. So let's crack on, let's get this whole differential all put together, then we can put it into the chassis. So the four-wheel steer was a complete disaster. It was way too twitchy for a vehicle that was so high. So I ended up taking out the rear wheel steer and just had it front wheel steer. I then found that the shock absorbers, all 8 of them, was way too stiff. So I ended up removing half of them. So we were back down to 4 shock absorbers. And then I found that the 2 motors was way too much power, because back in the day, batteries didn't last long even with 1 motor, let alone 2. So I ended up taking out the second motor. So what I ended up with was just a straightforward monster truck, and it kind of missed the point of having 2 motors, 4-wheel steer and 8 shock absorbers. So I eventually sold that car to a local model shop in Swansea when I finally passed my test and released a little bit of money. But also, while I was playing around with model cars before I got my driver's license, I actually got a Mardave Mini, and I've had lots of Mardave Minis over the years. And when I eventually did get my driver's license and I did actually move out of home and I got myself a home and everything else, I did actually start a Mardave Mini club in Pembrokeshire. And that lasted for a good few months and it was great fun. I absolutely loved the Minis. But obviously at this point, you may have guessed, I passed my driving test and I was off down the local club in Swansea racing every single week. And I was racing my Koshu Optima Pro and it did very well. But obviously things have moved on, because when I bought that car in about, was it 96, 97 when it first came out, by the time I'd got my driving license and I was down the club, we were knocking on the door of 1990. So I passed my test in 89 and racing that car for about a year, and that obviously meant that I was not really doing the best that I could on track with my Koshu Optima Pro, and I was racing Schumachers. So my radio controlled car racing days really got going in 1990 when I passed my driving test and I got my Schumacher Pro Cat. Those were the days when I really got going and I really made proper serious progress in my racing, and I usually ended up top of the B final. Sometimes I managed to scrape into the A, and if I was really lucky and all the good guys hadn't turned up, then I could get sort of halfway up the A, but I would never win the A. And there you are, that is the full differential completely finished and almost ready to fit in the chassis, or bar the rear cover. So as you can see, there is the differential working perfectly with this side locked, and then when you bring the locker over, it engages and then it locks the diff up completely. And that is how the locking diff works. Quite why you'd want a locking diff, I'm not entirely sure, but as you can see, the parts that I actually added to the inside is this brass piece in the middle and then these bars on the outside, just holding those planet gears in place, because there wasn't really much holding those planet gears in place apart from a little bit of plastic on here, and I wasn't entirely sure that that was enough to line up the gears and keep them nice and straight and stop them from pulling apart, because all the drive of the car was going through those gears wanting to spread, and there wasn't a lot, I felt, holding them. So I've added those pins and the brass bar in the middle with 2 grub screws so it actually locks them into place. And as you saw, I fitted a brass spacer on the end of this crown gear because I discovered afterwards this crown gear isn't quite right. It doesn't have a retainer for the rear bearing, and there's no spacer also to take the side thrust. And in the unsuspension plates, there is actually a new crown gear as well on that set of plates, so I could have used that, but I'd already printed this gear out, so it wasn't really worth reprinting one when I could just simply make a brass spacer instead. So let's get this rear cap on, and I can get this into the back of the car using these parts, and that concludes the chassis. I was always sort of B-class material. I like to think of myself as the best of the rest. I wasn't really good enough to win the A, but everybody else, you know, they were fair game. I could usually get them. And I'd never really changed from that position. I was always sort of top B class. So with the rear differential fully built up and a few little tweaks added to make it a little bit better and then fitted into the frame, that concludes the building of the chassis in its entirety. Now we need to move on to the rear suspension, and that's going to throw up a few little problems that I'm going to have to work around. So let me explain. Okay, so apart from a couple of tweaks in the differential, the kit so far has been going very smoothly. Unfortunately, we now get to the rear suspension. Now there are a few problems with this suspension. Now the owner of these files has set up a Facebook page, and I'm sure that somewhere in that Facebook page it says not to build the suspension version of this car because it doesn't work. Now I may be wrong in that statement, but that's what I think that they've been saying. But as you can see, I've actually got the suspension to work, and the axle works with its own little drive shaft, and this is how it's supposed to be, and there's no play in that hub at all, and it all works exactly as it should. However, this is the side that I just want to explain some things to you on. Now when you print out the files, you're supposed to print out one of these universal joints, and that's all great. So here are the 2 halves, just here, they print out like that. And this side goes in the hub. So if we pop the hub in there like that, you can see that that is how that fits, and then the UJ comes off that and then goes into the drive cup. So if I take that one out and I put my built up one in, and then I put that into the car like that, and then I try and lower down. Now this has all just been cobbled together, but the centers are correct, and if I try and lower that down so that the ball joint marries up to the top of the hub, you might be able to see there that there's absolutely no way that that ball joint is going to marry up to the hole that it's supposed to, because this drive shaft here is far too long. It just won't do it. The other problem that we've got is it's a little bit of a crude design really, and that is the actual drive is taken by a screw. Just like that. Now this side is reasonably acceptable, but this side is all sharp and spiky. So as the universal joint turns, it's going to be grinding up your drive cup. Now I've actually created this, which is a modified prop shaft. And as you can see, it's got 2 bolts either end, so we've got a nice smooth drive. And what I do is I make this, and I also machine out that little slot in there, because inside the cup we got a wide portion and a thin portion, and you need to machine out that thin portion to the same as that side there with a Dremel little ball cutter and make each side match, and then your new drive shaft will eventually go in like that, so that we end up with the drive shaft over here doing exactly that. Now when I printed out these 2 hubs, one of my hubs had a flaw in it right through the middle, and one of them failed, so I had to isolate the one that didn't fail and print it out again. So just be aware on your slicer that you actually make sure that one of your hubs doesn't fall apart, and if it does, delete that file and just duplicate the other one that doesn't fall apart, and that'll take care of that. Now there's one other problem as well with the rear suspension, that being these ball joints. Now this is the standard ball joint that comes with the kit, and as you can see, that has got no chance of working. It is really loose. But what I've done with the ball joint, I've created these. Now the ball itself is 10% bigger making it 9.6 millimeters across its diameter, but the height is exactly the same as a standard ball, and that then fits perfectly inside your suspension cup or your ball joints when you come to assemble it. So that we got a couple of things. Make sure that your hub doesn't fail in your slicer. We need to make a new drive shaft, and we need to make some new balls. Now, I'm not a very good person on Tinkercad, or CAD for that matter, but I'm going to do my best now to quickly walk you through Tinkercad and show you how I made this prop shaft and show you how I made a set of these balls. So I'm not very good at CAD, I'll do my best. Tinkercad is the only tool that I can work, so we'll go with that. But if you're very good with a proper CAD software, then this will be a walk in the park for you. But I'll just run through and show you how I did it on my particular car. Okay, so I don't want to make this video all about how to use Tinkercad, but it's very easy to use. I'll assume that you're happy to go onto Google and just find out how to use it, or you can work it out yourself. It's very intuitive, and I learned how to use it pretty much entirely myself without having to go onto Google. But if you do get stuck, just ask Google AI or just go onto a YouTube video. There's tons of videos out there showing you how to use the tools in Tinkercad. And like I say, it's a very simple tool to use. So this is a prime example here of what I was telling you about, taking the files from this particular hot rod and bringing them into Tinkercad. You can see from this example here, it stood my prop shaft right up on end, and that is never ever going to print that way. So there's a classic example here of just be careful when you import files to Tinkercad or indeed into Bambu Studio. Just make sure that they do lay down flat. Now, the beauty of bringing these parts in via Bambu Studio is that you can choose a flat surface in Studio to lay it on. With Tinkercad, you'll need to lay it down manually, find the flat surface and adjust it angle by angle, and then get it to lay flat on the deck. And if you just can't quite get it right, you could also use a hole tool and then lay a hole tool underneath there, bring it down to something like 0.1 of a mil, and then just slice the bottom to make it flat. Then you can press Control D and drop it to the surface and it'll be completely flat. So you can see now in this particular image here, that is more or less what I've done. And I've put it upside down because if you'll see, the ball has got one flat surface and the other side doesn't have a flat surface. So this was the ideal side for me to put it on. And I've used it on the underside view there just to show you that it's the actual underside of the prop shaft. So you need to get it down level on its surface there and lay it down nice and level. Then what I did is I brought my hole tool, which is what this thing is called, this big box here, this delete tool. It's called a hole tool because it makes holes. So you can put it on different surfaces. So I put it on the underside surface of that main oval down the length of the shaft, and then just extended it all the way across to make the bottom of the prop shaft completely flat, as you can see in this picture here. So once I got it completely flat and pressed Control D and slammed it to the deck, I then brought another hole tool in and removed just about all of the prop shaft right up to that little blemish that's actually in the prop shaft there, you can see on the left hand side there. Then simply use the hole tool to cut the prop shaft. And then turn the part around so it's facing in the opposite direction, brought it into the middle of my control board. Then I made a tube, made it 3mm by 6mm, and then inserted it into the center of the prop shaft hole, level to the top surface of the prop shaft. And then I amalgamated all of it together to make one solid object. Then I flipped the prop shaft component over to expose the small hole, and then made up a long hole tool that was 1.75mm in diameter in both directions and about 14mm high. The height doesn't matter as long as it's longer than the ball, as you can see in this image. Then I squared it up nice and square within the ball hole, and then congealed the whole thing together so that I actually reinstated the hole all the way through the ball. Then simply duplicated that part, made two parts, then turned the second part around so they're now facing each other, and then slid them together. Now the way that I measure on Tinkercad is a little bit weird because there is no easy measuring tool. So as you can see here, I brought in a solid object and I've brought it up to my dimensions, as you can see in these pictures here. And the size that I ended up going for was 50mm long on the outside. So once I got my prop shaft measured to the correct length using my little tool that I did, I then deleted the tool and simply duplicated the part into a pair and uploaded and exported as an STL and put it straight into Bambu Studio and printed it. So the way I created the larger balls, if you click the object, it gives you length, width and height. If you click and hold the height box and then press Control, you can drag the whole thing and make the whole thing bigger or smaller in proportion. So with that little bit of knowledge to hand, I created another one of my flat tools, as you can see here in red, and I actually made it 9.6 by 9.6. Then I slid that into the middle of the ball, and then I used that expansion tool that I just said by holding the vertical box and pressing Control, and I expanded the ball until the ball fitted the square perfectly. Now you do have to change the height of the square as you make the ball bigger, so you sort of balance the two, balance the proportional diameter plus the diameter of the square until they all fit nicely, and you'll end up with the ball fitting the square perfectly like this picture here. Once you've done that, you can delete your 9.6mm tool and replace it with a vertical tool at 11.8mm, and then simply duplicate the ball twice. And then you'll want to bring in the hole tool again, and you'll want to delete the ball off of one ball and delete the post off the opposite side, making sure that you have a little bit of overlap. And then you simply delete each piece of each part. Make sure you keep these operations separate, because otherwise if you group them together, the whole part will become one and you won't be able to bring the ball to the post. You'll need to make these things separately so that they act separately. So once you've got the two separate parts, you can simply slide them over each other and then use the alignment tool to align them up absolutely perfectly. Then just simply slide over your height tool, the little red height tool there, and adjust the height of the ball so that it just snicks the top of your height tool. And then simply remove your little tool and then congeal the whole thing together, and then you can simply import that as an STL into Bambu Studio and duplicate it in Bambu Studio. I think I made about 8 at the same time and printed them all off. Now when you come to fit these larger balls into the existing parts that you've 3D printed for your suspension, you will find that they are incredibly tight. You'll never get them into the socket because the socket in the suspension part is so tight, the ball won't fit. The ball barely fits when it's too small, and it won't fit when it's too big. But as you see here, all I'm simply doing is dipping them into very, very hot water. It's fresh out the kettle but not super boiling. And once you do that, you can actually push the ball into the socket as long as you're quick. And if you make a right mess of it, you can always print out the suspension arms again. But I managed to get mine done first time, and they're all perfectly good. And the ball and socket runs beautifully in the actual joint, and there's no more problems with the balls and sockets on the rear of the car. Okay, so moving on to the engine block, and these are all the parts you need to make the motor. So you may notice that I've got a slot in one side of my block and not a slot in that side. Now, as this block got printed off on the set of plates to print off, it actually came with no slots in there, and I went onto the Facebook group and asked, why can't I get my motor bracket in there? And the reason why is because that one that I printed off, or this one, was a mistake. It should have had 2 slits in it like this one side here, but that this file was included in the files, but it just hidden away. So obviously you would naturally print off the one that's on the plate and then you wouldn't see the corrected one. So I ended up printing off this one, which is a bit of a waste of time. So I ended up slotting out by hand on that side, which is all I actually needed to get my motor plate in. So the correct version does exist on the plates, but my one is slightly different. So the next thing is this motor plate here. This motor plate is actually wrong. If you line up the holes to mount the motor, and they'll only go in 180 degrees apart, you will see that those wires come out on this ear side, and if you turn it around the other way, it's exactly the same position because it's 180 degrees opposed. Now that can't work because there is literally nowhere in that motor block for those wires to come out sideways. It's completely impossible. I suppose you could always dig away the side of the motor block there if you had to and bring the wires around, but you're still bringing the wires really tight around inside that block because there's not a lot of material really in there, and you're going to bring those wires around very tight to the spinning outer part of the motor. So this plate is actually wrong as well. So what I've done is I've recreated that plate on Tinkercad, and I've turned those mounting holes through 90 degrees. So now my wires come out the top just like that. Now there is a slot in the block to take wires, but obviously with the motor in there, there's no way you're really going to be able to bend those wires around the bottom and bring them through that gap. It's just too tight. So I'll orientate my motor like this, bring those wires simply over the top, and I'll scallop. I didn't even need to scallop out, it's already got a hole. So those wires will just go up inside that blower and it'll all be hidden very, very nicely. Just one last thing to note before we start bolting the motor together. This set of parts here that goes into this transmission case is actually a reprint. There are two types of files for this particular part. One that involves 3 tiny screws in each gear, and one that just involves one M3 screw. Apparently there's no difference between the two. One just uses a single screw and is easier to assemble, and the other one uses 3 screws, which obviously needs more hardware and a bit more of a faff to build. So I printed out both, and I've elected to use the single screw version, which is in the revised folders section. So that's just one thing to note. And the casing apparently is exactly the same, but I've also printed this out anyway. And all these parts are printed in PETG for strength. So let's crack on. Let's get all this motor all put together, and then we can get this into the chassis. And I'd never really changed from that position. I was always sort of top B class and maybe bottom A if I was very lucky on the day. But I had all my racing experience of my Schumacher Pro Cat. I absolutely loved that car. It ran really well, and I absolutely did appreciate the crash back front end where it was all held together with elastic bands and you never broke a front wishbone. But those days had to go, and as you do with racing, you move on. And then I bought myself a Cat 2000. And that didn't really progress me all that much. I still ended up being top B final with it, and I raced that for a good few years until Dave brought out the Cobra. Now I had a bit of a change of heart then. I decided to go 2-wheel drive just to try what it was like, and I really enjoyed the Cobra. The Cobra was the first car that Dave made that was actually very, very good as a racing car, and I really enjoyed that car, and it really made an impression on me. And that's pretty much what I had right to the end of my racing days. That stopped in about 97, I would say, about 1997. And then I actually bought myself a Traxxas Stampede that I could play with when I wasn't racing. So I'd play with that in the street and up the park and everything else. And that was a really, really good car, the Traxxas Stampede. I was amazed at how well it handled. It would almost never roll over. But that's what I played with when I wasn't racing. Okay, so at this point it's time to move on to making the tyres from 40 Shore PU rubber. Now there are a number of different ways I could have done this, but what I've finally decided to do is to mould this tyre exactly as it is here, not hollow out the middle and create a cavity, because what I'm going to do is I'm going to make a core of this closed cell foam rubber made from a yoga mat. I'm going to cut it up into strips, I'm going to create a circle similar to that, and I'm going to mount it inside the rubber mould, pinned so it stays held in space, and then I should pour the PU rubber over it. I think that will be best because that will give me a lovely flat surface then to put the 3D printed wheels in exactly as they were designed. It also not use quite as much rubber because it's quite heavy, and it'll give me a sort of a softer foam core to give a little bit of cushioning in the tyre. So it'll kind of do all sorts of things. Plus also this foam is very, very light. So let's crack on. Let's make a rubber mold for these, get some foam cut and make some tyres. So while I was playing with my Traxxas Stampede and bombing up and down the street, I also started a Dave Mini Club, which lasted probably a whole summer, and that was absolutely fantastic fun, again in about the mid-90s. Though we had quite a few members in that club. I started it myself. I think we ended up with about 10 members, which is not bad for our small village, and it was a right blast. Those cars are really, really good, and I've had a Dave Mini ever since, and I've still got a couple now in the loft here. So that was what I was basically doing until the middle of the 2000s, when my youngest daughter wanted to go model car racing, and she ended up with an RC10 B4, and I started back off with an RC10 B44. So I'd sold my 2-wheel drive and I was starting to race with a B44. Now I didn't realise that you could actually dent a Lexan body, because up to this point in all my model car history I'd not ever dented a Lexan body, so I thought they were pretty indestructible. But what I hadn't realised is that the etiquette of racing had changed since the 90s, and now we're in the end of the 2000s or somewhere around there, and it had all gotten a little bit kind of get out my way, I'm coming through. So after the first evening of racing with my brand new RC10 B44, I had 2 very significant dents in my Lexan body. There was 7 colours and taken me about a week and a half to paint, and I was incredibly angry because cars were never cheap, And the B44 was certainly not a cheap car. It was all lovely and shiny as Lexan is when it's brand new and not been handled, and now it had 2 whopping great big dents in it, and the racing was a little bit adversarial to say the least. So I raced it a few more weeks, but I got a bit fed up with the way that modern cars with their LiPo batteries and also brushless motors had so much power that you could go into a corner in all sorts of ways and come out of it in all sorts of ways but still stay on the track, which is something that I wasn't really used to. But with the modern power supply, you could definitely do that. And I was finding 4-wheel drive a little bit of a lottery and a little bit of a problem. So I ended up going back to 2-wheel drive, because with 2-wheel drive there tends to really only be one racing line, and if you're on it, you're fine. If you're not on it, then you tend to go very wide, and it gives somebody else the opportunity to go round if they're on the correct line, which is not really what you get in 4-wheel drive. So I went out and I bought myself a Schumacher Cougar. And I absolutely love that car. That worked extremely well. It's a Cougar SV and it's very stable, and the tyres would last 3 to 4 weeks as long as you didn't mind a bit of understeer on the 4th week. Of course, racing being racing and the latest and greatest thing, I decided to sell that car and I bought myself a Lossy XX. I think it was a Lossy XX. I can't honestly quite remember. Anyway, that car was absolutely phenomenal. But the only trouble is it would only last 2 weeks and then the tyres would lose. And then once the tyres had gone off, the car was all over the place. So obviously you can imagine 2 sets of tyres in 1 month got really expensive, and I soon got bored of buying tyres to keep the performance of that car absolutely 100%. Okay, so now the wheels and tyres are on the car, and yes, they do look fantastic, and the model is now so big I can't fit it on my table, so I have to resort to pictures like this to show you. We can now move on to the suspension. Now I did read on the Facebook page somewhere, I'm sure, that the suspension chassis can't actually take the suspension itself because the body is too heavy for the actual springs. Well, in the instructions, the instructions call for a 1.2mm spring, but I've actually bought a 1.5 and a 1.8, and I'm hoping that the 1.8 will overcome the problems of the suspension. Now, fundamentally, the shock absorbers are laid down almost at that sort of angle, so very little upwards movement makes the shock absorber move a very small amount. That's not all that efficient. Really, the most efficient way is in that orientation. So I'm hoping that the 1.8mm spring will actually do the job, and for that very small amount of travel, for the very small upwards movement, the 1.8 spring will be strong enough. However, we could move the shock absorber up a little bit, which would improve the travel. Alternatively, we could put double springs on the car, or possibly even get the springs all the way upright in that position on a different position within the chassis and the suspension arm. So I'm going to have a play around with these and I'm going to see what I can come up with. But I did also say I was going to show you how to cut springs in this video and clean up the ends so they're nice and flat like that. Because a lot of people just cut the spring and you end up with this horrible hook on the bottom, and it makes the spring all wonky in its holder. So I'm going to show you how to cut the spring, heat it up, flatten it out, and then grind the end nice and flat so you get a nice flatted end like that. Because the instructions call for a 55mm long spring. I could find 50mm and I could find 60mm, but I couldn't find any 55. So I bought these foot long pieces and we're going to chop them all up. So let me get to the bench and we'll show you how to chop the spring. I'll have a bit of a play and we'll see if we can get this car's suspension properly working. Okay, so now we've got the car up on wheels, we can now turn our attention to trying to get the spring rates about right. Now, as you can see, the end of that spring is nicely folded flat. It's not quite perfect yet, but it's close. The other end has been cut. Now, I've had a play with this 1.8mm wire to see where I'm going with the spring, and I think I'm in the ballpark. But you can see a typical end of a spring like this. So that's not what we want, and that's what a lot of people do. They just cut it off and use it because they don't know how to collapse the end of the spring down. But it's very, very easy. So this is how you do it. In the case of our spring, we want a 55mm long spring, and like I said, I couldn't find a 55. So I've got 55 on my gauge here, and I'm going to the bottom of the spring, and you can see that this loop here, or this piece of wire here, is exactly where we want to be for 55. But we need to collapse the end down. So I'm going to come to this point here, to the next one up. And that looks about right to me. By the time you collapse this one down, it'll be about 55. So you could either use a Dremel or a really strong pair of pliers. I've elected for the strong pliers because it'll go through just like that. And now we've ended up with a spring That's a little bit longer than we need. So all we do next, it was literally heat the end up to red, cherry red. So I'm going to fast forward this a little bit. And then once you've got it cherry red, get a piece of steel and then push it nice and tight against the steel, just like that. And you've actually collapsed the end of the spring. So there's one last thing to do, and that's just grind it flat. So we'll take it to the grinder, and we'll put a nice flat on this end and that one. So once you've finished on the grinder, you should end up with two nice flat spring ends just like that. And if we take our measurement across those two flats, we can see that we're still right on 55mm, almost exactly, which is perfectly good enough. And this particular method works on all sizes of spring. This is a little bit big for my little blowtorch, but as you saw, a little bit of dwelling with the heat does it perfectly well. But with smaller springs, it'll happen a lot quicker. You'll heat up these coils much quicker. And don't heat all of the coil. You want to put most of the heat in the first half and a little bit less heat in the last quarter here. So you're squashing down about 3/4 of the spiral, if you like. So you end up pushing it down just like that. So there we are. So we'll try these now in the car. I'll have a play around and I'll get back to you when I've found the right combination front and rear. Okay, so we have success. As you can see, we've now got working suspension on the back of my car. Now I did originally make a set of 55mm long 1.8mm springs, just like these, and they were very good, but they're a little bit stiff. So I took off half a coil off the 1.8, brought them down to 50mm long and fitted those, and they were really good. The suspension would collapse down just a little bit under the weight of the body and then actually balance out very nicely, but I wasn't quite sure. I thought it might have been a little bit too stiff when the model is completely finished. So I elected to use the 1.5mm wire in the end and cut it to the stock 55mm long, and that's absolutely perfect. When the body is on, or the weight of the body is on, it levels the suspension out from a droop to a level, and then you've got all that extra movement beyond that. So I think that is absolutely perfect. A 1.5mm wire cut to 55mm stock length, and I think that will be absolutely perfect. Now obviously I've got to run the car at the end of the video. If it doesn't work properly, I will let you know. If it works properly, I will just say nothing and we'll move on. So that's working for the rear, and as you can see from the front, we have really good suspension. Now I did conversely feel that this front suspension was possibly a little bit too soft, and maybe I could go up to a 1.5 on the front from a 1.2 standard. Again, 55mm long stock. But to be honest, I think I'm happy with the stock length on the front. I think it works quite nicely and I don't foresee any problems. But again, if I decide to go up a grade to 1.5mm, I'll say in the comments at the end of this video. But at the moment, I think I'm happy with the suspension. It all works really well. So with that said, let's crack on and let's get the body finished. So I ended up selling it within a couple of weeks, and I went back to another Schumacher Cougar SV and I bought it brand new again. So that was 2 cars and a handful of months. And there you are. So I went back to my Cougar and really enjoyed the consistency of that car, and it ran incredibly well like the first one did, and I carried on racing with that. I did also rejoin another Mardave Mini club locally to here, not my club, it was a totally different club, and we raced Mardave Minis in there for quite a few weeks. I'd recommended that we give them a go, and everybody loved the car. The only trouble is, then we had a summer break, and Schumacher then released their little Schumacher Atom GT12. That just changed the game, because everybody in the club ditched their Mardave Minis that they'd only owned for a few weeks or just before the break and came straight back to club racing with these Schumachers. And they said, oh, don't worry about it, they're all the same performance. And I knew they wouldn't be. And everybody bought these Schumacher Atoms and they completely left the Mardave Mini for dead. So before long I had to buy one of those as well, which kind of ruined it a little bit. And it all went a bit south because it took away from the fun, cheap aspect of the hobby where everybody had exactly the same car. Now they've got these Schumacher cars, beautiful as they are, quick as they are. It all came back down to sort of the best driver would win, and it wasn't so much about the car, it was about how much money you could throw at the tyres and the speed controller and all the rest of it. And it took it away, really, for me, from the essence of the original Mardave Mini sort of ethos of cheap, budget, equal racing. So that kind of died for me. And then I just literally left racing entirely. Not because of the Minis, I just moved on to different things. Helicopter flying, actually, for 12 years. So that was that. But I did actually have a Herboa Hyper 7. So a glow car, which I used to race around with my friend over in the local industrial estates and so on. And that was absolutely phenomenal. I've still got that car. Don't run it anymore. But yeah, it was an absolutely fantastic car, a really solid glow car. I also had a Lossy 8 as well for 5 minutes after that. Bought it second hand, and that was phenomenal. I thought my Hyper 7 was amazing, but the Lossy 8 was incredible. It was so much lighter and more powerful than my Hyper 7. But that didn't last too long because the motor was difficult to tune. I never really did get it to run right. I only went to the club with it a couple of times, and that kind of died a death. But the Hyper 7, highly recommended. And then a few years ago, I bought myself a Kyushu Fox VE. Now, for those of you that don't know, that is actually a 1/8 scale basher truck, sort of. It's solid axle, so it doesn't bash that well. It's a jack of all trades, master of none, but it is incredibly tough, and it is good fun, and I really enjoy it. And I used to do 17 shows a year with my business, and I used to find myself sleeping in my trailer or my car on the Saturday night in the middle of weird car parks and weird places, and I'd be all on my own. Come 5 o'clock when the show ended, all the customers and traders would go home, and I'd be left in the car park on my own for the entire evening. So that's why I bought the Fox, because I could take it out and I'd find all sorts of places to go and thrash it around. Local woods, car parks, playgrounds, all sorts of places. Stayed in a couple of schools, so I was bashing it around the parks, the car parks, and the steps and all sorts of things. And I still got that Fox. I still bash it around now. I've bashed it the other day, in fact. Really, really enjoy it. It goes extremely well. It's a really good solid truck. If you want an 8th scale basher, but you're not into bashing and you just want something that's really, really solid and will perform reasonably well, the Kyushu Fox is a really good car for that. Then a few years ago, I decided that I'd start getting into trail trucks. Not so much crawling, out and out crawling, but trail trucks and just walking around the local moorland and so on, with a nice scale truck. And I got myself a G-Made Buffalo. I also bought my daughter one as well, and we've been out a couple of times with those and had some good fun memories with those. And I also got on the WPL bandwagon, and I bought myself a Toyota C24. Now that is a phenomenal little truck. It's a little trail truck, 18th scale, that's incredibly good value. I bought the kit version, the metal kit version, and I paid about £110 for it, all in, ready to run, including a handful of extra metal parts from eBay. And that is a phenomenal little car for such a small amount of money. Its performance is unreal. I absolutely love that car. It's fantastic. I also bought myself a 3 Racing Crawler as well, a 3 Racing Crawler EX with a Mitsubishi body on it. That was pretty cool. I picked it up cheap on eBay. It's not finished yet, I'm still fiddling with it, but I did manage to get the chassis all working on it, and I put my old Buffalo tyres on it because I didn't use the Buffalo wheels. I used nice aluminium ones on my Buffalo, as we do. So I put the Buffalo wheels and tyres on my 3 Racing Crawler EX, and it works really, really well. So I got the gearbox working, and that's a nice little project for me to do. Nice little trail truck for a light duties, I would say. And then the other day, I got fed up with asking for a Tamiya Sand Scorcher for Christmas for the last 30 years. And I thought, well, it's 2026. I've been asking for 30 years for another Sand Scorcher. It wasn't happening, so I bought it myself. So about 3 days after Christmas, I went onto the internet and I bought myself a Tamiya Sand Scorcher re-release. And I've built that up and I absolutely love that car. Lots of memories. I'm just waiting to paint it. And as things go round in a full circle, I'm also saving up for a Subaru Brat re-release as well. So that'll bring me all the way around full circle, back to a Tamiya Sand Scorcher and back to a Subaru Brat. Just exactly where I started. And there you are. What a fantastic project this has turned out to be. I've loved making every second of this hot rod, and I think it's turned out awesome. Now, I'm sure that I read on the RC3DC's Facebook page that this model was really for intermediate 3D printers. Now, you may know I've only had my 3D printer for just 3 months. I've done a few projects with it, learnt a little bit, but not too much. So I would definitely class myself as a beginner. Even so, I've been able to produce this model with very few problems. There were a few things along the way that I wanted to tweak and change and had to look out for, but it's turned out really well. It wasn't anything that I couldn't handle at the time. So the two things to watch out for when you're making a project like this and you don't know quite what you're doing maybe is ask Google. Google has all the answers, and also learn on the job. If there's something that you see that's not quite right, you think, well, if I could do that, I could probably get it done. Chances are you can do that, like making trees thicker, orientating parts in a slightly different way. It can all be done. Just ask Google and it will tell you, and you can absolutely make this project. So those would be my two biggest pieces of advice if you want to take on a project like this. Ask AI and learn on the job. There's no substitute for learning on the job. It'll teach you all sorts of things that you weren't quite prepared for. So I've really enjoyed this model, and I hope that you've really enjoyed watching this video, and I hope that you've learned something, and maybe it'll give you a little bit of encouragement to just go that little bit further and build something like this if you thought about doing it but you weren't quite sure and think, I'm not quite good enough. I think you probably are good enough. If I can do it, anybody can do it, and trust me, I'm rubbish on computers. And also, you may have noticed that I actually did get my Subaru Brat in the end, so now I've got my Sand Scorcher, my Subaru Brat, and now an awesome 3D printed hot rod. So I hope that you've enjoyed this sort of content, and if you have, maybe you could hit the little bell button and subscribe. So until the next time, thank you very much.